Good morning, student. Today we will discuss second qualitative property, elevation in boiling point. Elevation in boiling point. Elevation in boiling point, that means increasing in boiling point. Now before discussing increasing in boiling point, we have to clear the definition of boiling point. The definition of boiling point. The definition of boiling point is the temperature at which a vapor pressure of liquid becomes equal to its atmospheric pressure. That means liquid may be solid or solvent. The vapor pressure becomes equal to atmospheric pressure. At this temperature, liquid will start to boil, and this temperature is known as the boiling point of liquid. That means boiling point depends upon the atmospheric pressure. If the atmospheric pressure changes, then boiling point also changes. Now, boiling point of water, we know very well. Boiling point of water. Boiling point of water is 100 degrees Celsius. That means 373.15 Kelvin. But at which pressure? This boiling point of water is at 1 atm pressure. If the pressure, atmospheric pressure changes, then boiling point also changes. 1 atm pressure, that means 1.013 bar pressure. Now, our topic is elevation in boiling point. So, what do we mean by elevation in boiling point? So we considering one as a solvent. One component is solvent, second component is a solute. Now, TB0 is the notation for the boiling point of solvent, boiling point of pure solvent. And TB is the boiling point of solution. Now, elevation in boiling point, that means increasing in boiling point. If we are adding solute, non-volatile solute, we are adding in volatile solvent, then solution is prepared, boiling point of solution is TB. Now, when non-volatile solute is added in volatile solvent, and the solution is prepared, then boiling point increases. Boiling point increases. Why boiling point increases? Because we know very well vapor pressure of pure solvent. Vapor pressure of pure solvent is higher compared to always vapor pressure of solution. That means vapor pressure of solvent, pure solvent is higher. That means heating is required less to reach the pressure, that means up to atmospheric pressure. That means always TB is greater than TB0. That means boiling point of solution is always greater than boiling point of pure solvent. And this difference, that means delta Pv equal to Pv minus Pv0, and this is known as elevation in a boiling point. That means delta Pv is known as elevation in a boiling point of solvent. That means after addition of non-volatile solute, boiling point of solution increases. Again we are discussing why Pv greater than Pv0 by graphical method. That means when we are plotting the graph of vapor pressure versus temperature, that means we know very well vapor pressure depends upon temperature, and we are plotting graph of vapor pressure of solvent and solution with respect to temperature. That means when we are plotting graph on y-axis, it will be vapor pressure. Vapor pressure is in atm unit. That means atmospheric pressure atm unit, and here temperature. Temperature will be in Kelvin unit. Now, if we are plotting the graph of vapor pressure for the pure solvent, temperature increases, vapor pressure increases. That means suppose here the solvent is there. Now as the temperature increases, vapor pressure increases. Now suppose here this pressure is 1 atm. Then when the vapor pressure of solvent, this line is for solvent. Now as the temperature increases, vapor pressure of solvent increases, and finally when it becomes equal to the atmospheric pressure is 1 atm, then this corresponding temperature is known as, that means Pv0 is known as the boiling point of pure solvent. That means when the vapor pressure becomes equal to the atmospheric pressure, then the temperature is known as boiling point. So here this point indicates the boiling point of pure solvent. Now we know very well when non-volatile solute is dissolved in volatile solvent and the solution is prepared, solution having lower vapor pressure. Always solution having lower vapor pressure compared to pure solvent. That means solvent line of graphical line of solution will be downward compared to solvent. That means suppose here solution is there under the same condition, then the vapor pressure of solution is lower. Now we are increasing the temperature, then vapor pressure increases. That means this graph is for solution. As the temperature increases, vapor pressure increases, and finally when the vapor pressure becomes equal to 1 atm, then this corresponding temperature is known as the boiling point of solution. This point is known as Pv, that means boiling point of solution. This graph is for solution. Now from graph we can see Pv is greater than Pv0. Here also Pv greater than Pv0. This difference is known as delta Pv. Otherwise elevation in boiling point of solvent. Now how to calculate elevation in boiling point of solvent? So for dilute solution, experimental results show that elevation in boiling point is proportional to the molality of solution. That means delta Pv is proportional to m. What is m? So m equal to molality of solution. Now when this proportionality is removed, then proportionality constant we have to add, that is known as AB. That means AB into m. So remember this formula. Delta T equal to Kb into M, where Kb, what is Kb? So Kb is known as boiling point elevation, constant. Otherwise it is known as molar elevation constant. Molar elevation constant. Otherwise it is known as abilioscopic constant. Abilioscopic constant. So remember this formula, delta Tb equal to Kb into M, where M is molality. Now molality of the solution can be expressed in simple in terms of mass of solute and mass of solvent. Then remember, 1 is solvent, then 2 is solute. Then molality can be written as W2 into 1000 divided by M2 into W1. Now what is W2? So W2 equal to mass of solute. We have to take mass of solute in gram. 2 means solute, 1 means solvent. Now M2 means molar mass of solute. What is W1? Molar mass is taken in gram per mole. What is W1? So W1 is known as mass of solvent. Mass of solvent is taken in gram. So mass of solvent taken in gram. Okay. Now when this is substituted here, then we can get delta Tb equal to Kb into W2 into 1000 divided by M2 into W1. So remember this formula. For the calculation purpose, if we know the delta Tb, Kb, W2, W1, then we can calculate M2. That means molar mass. Molar mass of the solute can be calculated if we know delta Tb, Kb, M2, W1. Then we can calculate W2. That means in short, 1, 2, 3, 4, 5 variables are there. 4 variables will be given in exam. So we can calculate remaining variables. Now about Kb, definition of Kb and unit of Kb. So what is the definition of Kb? So delta Tb equal to Kb into M. That means when the molarity of the solution is unity, that means 1 molar, then elevation in boiling point becomes equal to the Kb. That means definition of Kb we can write like this: elevation in boiling point of solution when molarity of solution is 1. That means unity. Okay, at that time the elevation in boiling point is known as the molar elevation constant. Now what will be the unit of molar elevation constant? So we know delta Tb equal to Kb into M. Therefore unit. Now Kb equal to delta Tb. So delta Tb generally we are taking in Kelvin. That means Kb equal to delta Tb upon M. Now delta Tb having unit Kelvin, again molarity. Molarity means numbers of moles of solute per kg of solvent. That means here mole per kg unit. That means we can write unit Kelvin, kilogram, mole inverse. So this is the unit of Kb. Now on which factors Kb depends? So Kb is the characteristic of solvent. That means Kb depends upon the nature of solvent. As the solvent changes, value of Kb changes. That means Kb depends upon nature of solvent. Nature of solvent. That means different solvent having different value of Kb. For particular solvent, how to calculate the value of Kb? So for particular solvent, it can be calculated using this formula. Kb equal to R M1 Tb0 square divided by 1000 into delta H vaporization. That means we can write like this, delta vaporization H. By this formula we can calculate the value of Kb for particular solvent, where R is universal gas constant in proper unit. M1, 1 means solvent, that means molar mass of solvent in gram per mole. Tb0 means boiling point of solvent in Kelvin unit. And delta H vaporization, that means enthalpy of vaporization of solvent in proper unit, that means it is taken in joule per mole, and at that time value of R will be taken in joule per mole Kelvin. So by this formula we can calculate the value of Kb for different solvent. And remember always, value of Kb depends upon the nature of solvent.